Hello, today we are looking at lesson 4 of our quadratics unit. Today's lesson, operations involving radicals, isn't really the typical quadratics that we're used to, but we will do some quadratic with radicals. Okay, so what is a radical? It's a square root. Actually, I'm just going to put a root symbol because it could be cubed root or quartic root. So a root symbol, that makes it a radical. The entire radical, a radical with a coefficient of 1. Okay, and a mixed radical is a radical with a coefficient other than 1 or 0. And for mixed, we want to use integers only. Okay, an example, so an example of entire radical would just be the root of 11. And an example of a mixed radical would look like that. So 3 in front of the root 6. To convert from an entire radical to a mixed radical, we need to essentially reduce or factor. Let's say reduce, factor. What is under the radical sign? It is helpful to break up the number into a multiplication question involving a perfect square. Okay, so we always want to be looking for a multiple of the number in the root sign that can then be square rooted. Okay, so for example, 72, there are multiple ways to multiply to 72, but the one that we can think of that has where one of the multiples can be square rooted is the multiplication of 36 and 2, because you can square root 36, so what this becomes is 6 root 2. Okay, if our number has more than one factor that can be square rooted, we want to go with the largest one. Okay, so we could have divided 72 by 4 and did 4 and 18, which would then be 2 root 18, but that 18 can then be broken up into other things. So just to save ourselves some steps, let's use our multiplication and division knowledge and go with the largest factor that can be square rooted. Okay, 5 root 27. So the 5 stays in front. We're going to break that root 27 into root 9 and root 3 because we can square root 9. So when we square root 9, we get a 3 now in front of the root 3. And because they're numbers, the 5 and 3 are right beside each other, separated only by brackets, we can multiply those. 5 times 3 is 15. And the root 3 cannot be broken any further. So the answer is 15 root 3. Okay, and one more. So multiple ways again to get to 120. But 4 and 30 is going to give us a rootable number. The square root of 4 is 2. Okay, and then if you look at all the factors of 30, so we have 1 and 30, 2, 15, 3 and 10, 5 and 6. None of those numbers are square rootable, so we'll just leave it here at 2 root 30. To convert a mixed radical fraction, a mixed radical to an entire radical, we must put the coefficient back under the radical sign. And we never put a negative under the radical sign because you cannot square root a negative. Okay, so we're going the opposite way this time. So 4 root 5 So in order to put 4 under a root sign, we have to square it. 4 squared is 16, so the 4 turns into root 16. The root 5 stays the same, and then we just multiply those numbers. 16 times 5 is 80. So 4 root 5 is the same as root 80. Okay, this one has a -6, then root 3, but like it said, we do not want the negative under a root sign, so we're just going to leave it in front. We're going to square the 6 to get 36, and then multiply the 36 and the 3, so we get the negative of root 108. Okay, and then finally, we square the 2 to get root 4, and 4 times 15 gives us 60. Okay, so the rules, the square root of a times the square root of b will become the square root of a times b, or ab. Okay, a square root b times c square root d equals, you multiply the coefficients, and then in the root sign multiply the two values under the root signs. Okay, a little bit of practice here. Simplify root 5 times root 11. So this becomes the root of 5 times 11, which just becomes root 55. Okay, over here we have -4 root 6 times 2 root 6. So we are going to work with our coefficients first. So -4 times 2 is -8. Then we'll work with our roots second. 6 times 6 is root 36. Okay. Well, we can square root 36. So it becomes -8 times 6, which is -48. Okay, that step of writing the root 36 and then square rooting that, if you are multiplying root 6 and root 6, or root 4 and root 4, anything where there are two roots in the same number underneath the root sign, you just really get rid of the root sign. Okay, like radicals. Radicals that have the that should be the same amount under the radical sign. This is useful. This is useful for adding and subtracting radicals. Okay, it is no different than collecting like terms. I don't know what just happened there. Collecting like terms. So the four sides of a quadrilateral have lengths root 8, root 18, root 12, and 2 root 3. What is the perimeter of the quadrilaterals? So for perimeter, we're going to add the four sides together. So we have root 8 plus root 18 plus root 12 plus 2 root 3. Okay, so none of our root signs have the same value underneath the sign, so we can't add any of these together, but we can simplify some of these. Root 8 can break into root 4 root 2. Root 18 can break into root 9 root 2. And root 12 can break into root 4 root 3. We have that 2 root 3 at the end. Good. So now each of them has a square rootable number. Root 4 becomes 2. Root 9 becomes 3. Root 4 becomes 2. And now we have like terms. Okay, so we have root 2's and we have root 3's. So when we put these together, the root 2's, we have 2 root 2 plus 3 root 2, so that makes 5 root 2. And we have 2 root 3 plus 2 root 3, so plus 4 root 3. When we add or subtract radicals, we can only combine the coefficients. Okay, so you see in the example we just did, the root number stayed the same. When we added root 2 root 3, and 2 root 3, it stayed as root 3. Again, this is just like collecting like terms. If you had 2x squared and 2x squared, it becomes 4x squared. You don't change that x squared. Okay, and then the quadratic part of this, let's simplify. So we have 3 minus root 6 times 2 plus root 24. So this is going to be a FOIL question. Okay, our first is 3 times 2, so 6. Then we have our outside, 3 times root 24 just becomes 3 root 24. Okay, we have our inside, negative root 6 times 2 becomes negative 2 root 6. And our last, where we have negative root 6 times times root 24, so negative root 144. Okay, then we're going to work through this simplifying. The 6, nothing can be done there. Okay, the 24 can break into root 4 root 6. We can't do anything with root 6, so let's just leave it as 2 root 6. And the root of 144 is 12. Okay, so we have 6 plus 3 times 2 root 6 minus 2 root 6 minus 12. So we have 6 plus 6 root 6 minus 2 root 6 minus 12. Okay, let's look at our like terms. We have constants, and we have root 6's. Okay, our constants first, 6 take away 12 is negative 6. And then we have 6 root 6 minus 2 root 6, so plus 4 root 6. And that's the answer.